Risk is characterized as a set of triplets. Number 1, the scenarios leading to the degraded performance with respect to one or more performance measures. Number 2, the likelihood, qualitative or quantitative, of those scenarios. Number 3, the consequences, qualitative or quantitative severity of the performance degradation that would result if those scenarios were to occur. Key elements of risk management planning: identification of stakeholders, establishment of risk tolerance criteria, thresholds, and elevation protocols, establishment of risk tolerance schedule for each risk, establishment of risk communication protocols between management levels, and delineation of the processes for coordination of risk management activities and sharing of risk information. NASA organizes its risk management systems into two complementary processes. Risk-informed decision-making, RIDM, informs system engineering decisions through better use of risk and uncertainty information and selecting among alternatives and establishing baseline performance requirements. Continuous risk management, CRM, manages risks over the course of the development and implementation phases of the life cycle to assure the requirements related to safety, technical, cost, and schedule are met. There are 6 steps involved when it comes to risk management planning. 1. Accept. A certain level of performance risk can be accepted. Number 2. Mitigate. Mitigation actions can be developed which address the drivers of the performance risk. Number 3. Watch. Risk drivers can be selected for detailed observation. Number 4. Research. Research can be conducted to better understand risk drivers. Number 5. Elevate. Risk management decisions should be elevated to the next highest level of management. Number 6. Close. An individual risk can be closed when all associated risk drivers are no longer considered potentially significant.
Identifying risks is an important aspect of risk management. Without identification, it is impossible to analyze and plan for actions. In identifying risks, you are collecting or gathering those related to your project. Typical methods of gathering risks include but are not limited to brainstorming assumptions and performing a strengths, weaknesses, opportunities, and threats or SWOT analysis. The overarching goal of these methods are identifying and examining the source and defining and categorizing the risk. Brainstorming is done to generate a comprehensive list and is usually done internally, led by a facilitator. Not all risks of a brainstorming session will be carried on to the end. Assumption analysis may be the next step after brainstorming, and as the project moves forward, some risks may be invalidated. A robust method of validating risks is in performing a SWOT analysis. By looking at the strengths, weaknesses, opportunities, and threats, a project can identify where they are vulnerable to risks and where they are most prepared to combat them. In this example, a check sheet is used to keep track of how many meteors strike a satellite each day of the week for 3 weeks.
Qualitative risk analysis involves analyzing how likely an event is to happen versus how much impact it will have. There are a few tools that can be used to help in this analysis. NASA currently uses a web-based database they call IRMA, Integrated Risk Management Application. IRMA uses some tried and true risk management tools, like the Probability Impact Matrix. This is a two-dimensional matrix that lists the consequences of a risk on the horizontal axis and the probability of it happening on its vertical axis. This creates a fairly easy to understand visual representation of risks and will give scientists and engineers at NASA an idea on where they should focus their resources. For instance, item 4107 is listed as a likelihood of 4 and a consequence of 5, putting this particular risk at a fairly high probability with a very high consequence. On the other hand, item 4622 has a likelihood of 3 and a consequence of 2. Red items will be prioritized first, followed by yellow, then green. Quantitative risk analysis is the process of trying to predict outcomes based on different inputs. A very basic way of doing this is to create a decision tree. This simple device takes various project possibilities and creates a branching path to project outcomes. Decision trees allow a project manager to quickly see how different variables will affect the outcomes. One very powerful tool is the Monte Carlo simulation. This is a statistical tool used to create hundreds or even thousands of simulations. This can be done using simple desktop software like Excel or in NASA's case, specialized software created just for that purpose. Scientists and engineers will collect existing data on the proposition, then run the simulations. In very short order, they can look at probable and possible outcomes and see where any possible issues may be. This technique is used in many ways on the International Space Station. Many of the scientific studies use Monte Carlo simulations, such as the studies currently done on radiation as it travels through various materials and on cosmic rays. Another way this has been used is to study the effect of the maneuvering thrusters of docking crafts have on the space station as well as on surrounding space. These simulations will help NASA engineers keep the space station safe, but also help design future spacecrafts.
Planning risk responses involves taking steps to enhance opportunities and reduce threats to meeting project objectives. Using outputs from preceding risk management processes, project teams can develop risk response strategies. Developing a response to risks involves developing options and defining strategies for reducing negative risks and enhancing positive risks. 4 basic response strategies for negative risks are risk avoidance, or eliminating a specific threat, usually by eliminating its causes; risk acceptance, or accepting the consequences if a risk occurs; risk transference, or shifting the consequence of a risk or responsibility for its management to a third party; and risk mitigation, or reducing the impact of a risk event by reducing the probability of its occurrence. 4 basic response strategies for positive risks are risk exploitation, or doing whatever you can to make sure the positive risk happens; risk sharing, or allocating ownership of the risk to another party; risk enhancement, or changing the size of the opportunity by identifying and maximizing key drivers of the positive risk; and risk acceptance, which also applies to positive risks when the project team does not take any actions toward a risk. For example, NASA uses a detailed risk response plan to plan risk strategies for any and all events.
Controlling risk is a component of the risk management process. This component monitors project success, assesses potential risks, and decides the best course of action in dealing with potential risks. Controlling risk has become an accepted inclusion in project management, especially in the software development industry. This addition has also extended the project manager's scope, spanning from the initial conceptual phase all the way to the retirement decommissioning phase. The risk owner is the individual responsible for controlling the risks. This individual creates risk mitigation and contingency plans that provide the risk threshold criteria, determined by identifying the risk probability and the risk impact, along with identification of any new potential risks. Another risk controlling measurement, time frame, is used to make a risk prioritization from the comparisons between risks. 3 measurements combined, probability times impact times time frame, generate a risk priority number. During each project review cycle, the risk owner provides an updated status of the mitigation plan and the contingency plan, allowing the project manager to watch or monitor the risk, accept the risk, only allowing a low impact risk to occur, mitigate or eliminate the risk, and close or retire the risk. If the risk requires action, the project manager uses resource leveling techniques for risk mitigation or risk elimination purposes. When controlling risk is utilized throughout the entire lifespan of a project, there is a reduction in the amount of defects or errors that occur. An example of an application that assists with controlling risk is NASA's Integrated Risk Management application, which is utilized for managing the International Space Station. The screen displayed below shows risk number 4115, where the risk owner is identified, the mitigation costs are displayed, and a quick snapshot view of the risk levels are indicated by the ISS risk matrix graphic.